Welcome to all. Next we discuss about non-ideal IV effects, otherwise called as second order effects. That means the IV cancer should be affected with respect to the following te- parameters like mobility degradations, velocity saturations, body effect, drain included barrier lowering, channel length modulation, subthreshold conditions, and gate leakage. First, we discuss about mobility degradation. V equal to nu E. Here, V is nothing but carrier drift velocity and nu is mobility of electrons. The mobility items in the above equations was assumed to be implemented of the vertical field E. This is a reasonable approximation when the electrical field is a weak but it breaks down for stronger electrical fields. Stronger vertical electrical fields can attract the charged carriers traveling along the inversion layer and cause it to collide with the oxide interface. This affects caused mobility degradation, where the effective mobility degradation with the increases in VGS. Under strong lateral electrical field is noted for VDS, the charge carriers are oscillated and the collision between the charges carriers and the silicon lattice increases. Beyond the certain level of electrical field, the carrier drift velocity saturation at V saturation. This is called as velocity saturation. Note that transistor saturation and velocity saturations are two different phenomena, but both them the result is saturation of current through the channel. V equal to nu E. Here E electrical field is nothing but VDS by L. Here L is nothing but channel length modulation. Next we discuss about channel length modulation. Reverse bias PN junction from diffraction region, the region between drain and source. Between this length is denoted for VD. Here L effective is nothing but L minus LD. Started L effective gives more current. So IDS increases with VDS and even saturation region. Increasing VDS causes deflection around the drain to widen. This pushes the pinch off point further away from the drain, resulting in the effective shorting of the channel. So del L equal to del D. Lambda is inversely proportional to the channel length modulation. So lambda is first factor on the precise value of lambda. Improved but approximate model for the drain current in the saturation. Here the drain current is nothing but IDS equal to nu COX by 2 into W by L within a bracket 1 plus lambda into VDS VGS minus VT whole square equal to the nu epsilon COX by 2 is denoted for beta by 2. Here beta is nothing but beta ratio. So 1 plus lambda by VDS is nothing but channel length modulation and VGS minus VT whole square. So it's generally this expression is denoted for saturation model. Generally electrical field effects are classified two categories: mobility degradation and velocity saturation. The vertical electrical field E equal to VGS minus T off. So attract carriers into the channel, long channel Q channel equal to directly proportional to E. So lateral electrical field E equal to V by VDS by L. So the long channel V equal to nu epsilon saturations. Thank you.